What is a discriminant? Given a quadratic formula, what's under the square root sign? So just b squared minus 4ac, that is called a discriminant. We sometimes write the discriminant as a Greek letter delta, so delta is equal to b squared minus 4ac. That just means discriminant is equal to b squared minus 4ac. We're going to consider three cases for delta. When delta, the discriminant, is equal to 0, and when delta is greater than 0. Lastly, when delta is less than 0. When discriminant is equal to 0, we have x is equal to negative b plus minus square root of 0 over 2a. But square root of 0 is just 0, so it's really negative b over 2a. Clearly, for this quadratic equation, we have an x value that's just 1. So in this case, we say it has a 1 root, or repeated root. When discriminant is greater than 0, we have x is equal to negative b plus minus square root of some kind of positive number because it's greater than 0 over 2a. Clearly, there are two answers. Negative b plus square root of a number over 2a, another one being negative b minus square root of a number over 2a. So in this case, we say this quadratic formula has a two distinct real roots. What does it mean to be distinct? In math, distinct means different. Two different real roots for the case of delta greater than 0. Lastly, we have a delta less than 0, so that means some kind of negative number. So x is equal to negative b plus minus square root of some kind of negative number over 2a. But square root of a negative number is a complex number. Therefore, in this case, we have no real roots. Using a discriminant, we're going to define the nature of the roots in the next slide. What is the nature of the roots? First equation, 2x squared plus 2x plus 3 is equal to 0. Our a is 2, b is another 2, and c is 3. So discriminant is equal to b squared minus 4ac, and plug in the numbers. 2 squared, 4, minus 4 times 2 times 3. Simplifying this answer, we have 4 minus 8 times 3, that's 24. So we have a discriminant that's going to be negative 20. So when the discriminant is less than 0, we know we have no real roots. Think about why. We know that quadratic formula says x is equal to negative b plus minus square root of a delta over 2a. If our delta is negative 20, we have a square root of negative 20. Therefore, it has complex roots, and it leads us to believe that this has no real roots. Right. Next question is similar to what we just have done, so please pause the video and try it on your own. We have delta is equal to b squared minus 4ac. B in this case is negative 4, so negative 4 squared. 16 minus 4 times 3 times negative 2. We have 16 minus times minus, that's positive. 4 times 3, 12. 12 times 2, 24. So in this case, discriminant is equal to 40. When discriminant is greater than 0, we have two distinct real roots. But why is that? We have a quadratic formula that states x is equal to negative b plus minus square root of a delta over 2a. Our delta is 40, so we have negative b plus minus square root of a 40 over 2a. Therefore, we have two different roots that are real, so we can say it has two distinct real roots. Given x squared minus 2x plus m is equal to 0, find the value of m so that equation has either repeated roots or two distinct roots or three no real roots. Let's first define our ABCs. A is 1, B is negative 2, and C in our case is m. So discriminant is equal to b squared minus 4ac. So negative 2 squared, that's 4, minus 4 times 1 times m. So we really have 4 minus 4m. For the case where it has a repeated root, that means your discriminant is equal to 0. So 4 minus 4m is equal to 0. Adding 4m's on both sides, we have 4 is equal to 4m. Divide by 4 on both sides, m is equal to 1. So when m is equal to 1, we have a repeated root. Number 2. For two distinct roots, your discriminant must be greater than 0. Again, our discriminant is 4 minus 4m. That has to be greater than 0. So negative 4m greater than negative 4. And dividing by negative 4 on both sides, we have m. Remember to change the sign because you're dividing by negative is 1. So m has to be less than 1 in order to have two distinct roots. Number 3. For no real roots, you want your discriminant to be less than 0. So we have 4 minus 4m is less than 0. Therefore, we have negative 4m is less than negative 4. Dividing by negative 4 again, change the sign, 1. So when m is greater than 1, we have a no real root. In this problem, we have kx squared plus k plus 3x is equal to 1. We want to find the value of k so that equation has two distinct roots, or two real roots, or a repeated root, or no real roots. First, we want to make sure that equation is equal to 0. So we're going to rewrite this as kx squared plus k plus 3x minus 1 is equal to 0. Since we will be talking about the nature of the roots, we need a discriminant. Discriminant is equal to b squared minus 4ac. In our case, our b is k plus 3 squared minus 4 times a, k, c, in our case, that's negative 1. So let's simplify this a little bit. Foiling this, we have k squared plus 6k plus 9 minus 4, k times negative 1, so that's positive 4k. Combine the like terms, we have k squared plus 10k plus 9. This is factorable, so we have k plus 1 and k plus 9. So we have 4 cases to consider. One is two distinct roots, which we know that has to be the discriminant greater than 0. Two real roots. We haven't talked about that one, so we'll come back to it. A repeated root, that means discriminant is equal to 0, and a no real root, that means discriminant is less than 0. Alright, going back. 2 real roots. That means just number 1 and number 3 combined. Number 1 clearly has 2 answers, and those answers are all real. For number 3, it's a repeated root. For sure, it has a real answer, but we're not so sure of the 2 answer part. The 2 answer part comes from the word repeat. The repeated root is actually a 1 solution that's repeated twice. So number 1 and 3 together is 2 real roots. So in that case, we have a discriminant greater than or equal to 0. So we can do this problem just like how we did in the last problem. Try all 4, or we can look at the easy and simple way by looking at number 3 first and drawing a number line and figuring out the rest. So let's do number 3 first. When discriminant is equal to 0, it has a repeated root. Discriminant, we already found, is a k plus 1 and times k plus 9 equals to 0. So we know that k has to be -1 and -9 in order to have a repeated root. After that, we create a number line, plot those 2 points, -9 and -1, and then we're going to represent the values of the discriminant above the number line. So first we're going to plot some points that are less than -9, such as -10, and in between -9 and -1, such as -2, and something that is greater than -1, always an easy one, that's a 0. So we're going to plot -1 onto the discriminant, which we already solved that discriminant has to be k plus 1 times k plus 9. So plug in the -10. We have -10 plus 1, that's -9, times -10 plus 9, that's -1. So -9 times -1, that's positive some kind of number, right? Here we're not interested in finding the exact value of the discriminant, but whether to see whether the discriminant is positive or negative. If we plug in -2, we have -2 plus 1, that's some kind of negative number, right? And then multiply that with -2 plus 9, that's positive. So negative times a positive number, right? That's going to give us a negative number for the discriminant. If I plug in the zeros, you get 1 times 9, or positive times a positive, that's going to give us a positive answer. So we know now the nature of the roots. For number 1, let's look at the answers. Need a different color. How about green? So number 1, if I'm looking at 2 distinct roots, that means the discriminant has to be greater than 0, and it's greater than 0 on -infinity to -9, but not including the -9, because if it's equal to -9, that's when the discriminant is equal to 0, right? So over here and all the way over there. So it's an open dot. So we can write this as k is less than -9 and k is greater than -1. For number 2, when it has 2 real roots, that just means number 1 and 3 combined, so k is less than or equal to -9, or k is greater than or equal to -1. Number 3, we already solved that k has to be -1 or -9. And lastly, for number 4, discriminant is less than 0 between -9 and -1. So -9, not including, right? K, not including -1. So that's it for this video.